Welcome to everyone. This is the second session of PyTorch geometric tutorial. And this year we decided to call it Advanced PyTorch geometric tutorials. And today we are gonna cover Open Graph Benchmark is the first tutorial. Let me first introduce the news of this year, the dates and everything. So to begin, welcome to everyone. I'm really happy to see you here. And okay, we started we were 3 guys. Now we are 26 on our Telegram group. If anyone else would like to join us, it's definitely welcome. We are also on the official library of PyTorch Geometric. There are our videos and our notebooks, so it's really a good news. The aims of this advanced PyTorch Geometric tutorial is to learn together, share GNN news, and discuss about models, idea, and basically is to do stuff together and finally, since everything is in the world is a graph, spread GNN to the words. What about the timetable? We are gonna have tutorials 2 times per month. So every 2 weeks, we are gonna keep Friday at 3 Italian time, 3 p.m. Italian time. You don't worry, you will receive a Google Calendar invite. We're here on Google Meet, and this is a, let me say, attempt of topics we are gonna cover, and with the dates. Of course, you can find it on the official website. And obviously, as usual, if you would like to present something, share your ideas, whatever you want, we have free slots. Since we are doing this 2 times per month, we still have time to introduce your presentation, your work, whatever you want. Just text me or Gabriele or Gianni, and you can present whatever you want. Okay, I think we can start. The table of contents of today are Open Graph Benchmark. Why Open Graph Benchmark? Open Graph Benchmark and PyTorch Geometric, some practice and some conclusion. So Open Graph Benchmark is a project that it's born a few years ago. It's quite recent work. I mean, yeah, let me say work, and is a collection of large scale benchmark dataset for machine learning tasks on graphs. And it's amazing because it allows to automatically download, process, split, and work with the dataset. It is, I like it because you have 3 tasks, prediction of nodes property, links property, and graph property. You have different scale, for instance, huge graphs, small graphs. So you will require to have, for huge graph, you will require to have GPU or stuff to advanced mini batching in an intelligent manner, but it's really good. And then I will come later. Let me just say 2 words about OpenOGB. It's structured in graph property prediction, and all the dataset already uploaded are OGB G, that stays for graphs and the name of the dataset. We have link prediction, that is OGBL plus the name. And we also have OGBN, that stays for node prediction, node property prediction. This is just a screenshot of the web page. As you can see in the node property prediction, you have dataset, you have the name of the dataset, it's okay, the scale, so if it's big, small, the task, the number of tasks defined on that graph, nodes, edges, the type of task, and you also have a metric. Why you have a metric, and I think it's the amazing part. Oh, let me get back on this in a few seconds. If you, for instance, are interested in one specific data set, you can click there, and you can see the information about the graph reference. You can see, in this case, the products coming from Amazon, as is an undirected and unweighted graph, contains Amazon products. There is the prediction task. There are a lot of information that help you to understand what the graph exactly is, so what you can do with it. And what I think is the really good idea is the leaderboard. In fact, if you go on the leaderboard for this graph, so for the products graph, you have a bunch of algorithms, in this case, mostly GNN, with information like the number of parameter, where they were run. So in this case, Tesla, Boo 100, and so on. You have when the method has been uploaded, and the amazing, you have the code that is really good. Finally, you have the test accuracy and the validation accuracy. So this is why here in the previous slide, I show you the metrics. So in some data set, there are accuracy in other rock, AUC, the curve, and it's really cool because you can run it, test your method, and see how state-of-the-art perform on that data set. And I think it's really, it will really improve the performance of the researchers, because I don't have to spend many time on searching competitors and stuff like that, because I already have here. So in order to answer why OGB, so is easy access to a data set. You can also load your own data set. So suppose you have your own collected data set, there is the procedure to load the data set. You can access to state-of-the-art performance, and you have the leaderboards. Of course, you can load your model. It's here. Of course, you can load, suppose that you develop a model, you can load on the leaderboards. There is this, let me say, operation to do, like, for instance, you have to do at least 10 different runs with a random seed in order to prove the stability of your results. And then you can load your model with in the leaderboards of the data set. So I think it's a really good idea to share results on this framework. Let me say that I see this in a Kaggle manner. I don't know if you know Kaggle. Is this platform in which there are some competition about machine learning tasks, and it's kind of a Kaggle for graphs. Okay, so I don't know if there are competition on open graph benchmarks, but I think it's a really, I mean, a good idea. Okay, open graph benchmark and PyTorch geometric, nothing to say. What I meant is that really you have to do nothing, because the downloaded object is ready for PyTorch geometric. So the object you download is, I mean, what we need, a data object for PyTorch geometric. So it's amazing. Let's see this in practice with really a toy example. Okay. So let's see in practice. Here I took an example from the library. The code has been developed by Matthias Fey. There is the official code in the link, but I just cut it and make more easily readable, removing more complex stuff. But if we have a look, what we are doing, simple as usual, we import the library. The library is for our GNN, whatever we need. We have our GNN. I'm not gonna explain the GNN because it's, we did it in the last tutorials. So let's say that we have our GNN, we define it. We have our train as usual, our test as we did. Interestingly, we also have here this new object called evaluator, but we will come back later. Let me just say to not consider for a second this stuff. Again, move, define the device, and here we start with Open Graph Benchmark. First of all, we get the dataset. So let's have a look at the object. Okay, at the import. Sorry, we are importing from Open Graph Benchmark dot node property prediction. We import PyGeometric node property prediction dataset. That is an object, and we import also an evaluator. Okay. The amazing part is that here with this function, we call it, we give the name of the dataset we want. We applied some transformation coming from PyTorch geometric. And here we are. Here we have the dataset downloaded and already built and works for our GNN. So are there other dataset? Of course. So for instance, if I call it with a wrong name, so without the real name, I can see that there are other datasets like proteins, products, mag, papers, and other stuff. What's next? Okay, so this was just a note. We have loaded the dataset. We here are defining some parameters of the network, so hidden layers, number of layers, the dropout, the number of epochs, when we have to print stuff, and so on. But it's just a matter of parameters. And here is the second, I think, interesting part of this talk is the evaluator. The evaluator is an object coming from Open Graph Benchmark that allows us to evaluate our model using the same format required for the leaderboard. So it's easy to compare the performance with the state-of-the-art algorithm. How to use it? Really, really easy. We call it and we pass the name of the object. Did you remember previously that I showed you in the test and I said, don't care about this? Okay, now we are gonna look at this. In the test phase, we also update the evaluator, passing the y true and the y predicted. As you can imagine, it depends on the type of the task. Because, for instance, in this case, we are in node property prediction, and if I try to do, I have instantiated the evaluator, and if I do evaluator dot expected input format, I return this information that tells me that for Open Graph Benchmark node archive, we need to have this dictionary of y true and y true, epsilon pred, y pred, and y pred. And here is what we did in the training, in the test phase. So at each test phase, we update the evaluator so that the evaluator is this object containing all the performance of the model required for that specific dataset. So just to show you, suppose we are interested in link prediction. I'm importing the evaluator from link property prediction object. And when I pass it the name of another data set for link prediction, link property prediction, I have, as you can see here, another format for the information that I have to give to the evaluator. And it's the same for, oh, sorry, here it's not link, it's graph. Because here I'm trying to instantiate an evaluator for a graph property prediction. And here it's required other informations. So end of this note. This was just to say that you can use this evaluator for each of these three macro tasks. So node prediction, link property prediction, and graph property prediction. And each of those has three different information that they require to compute the matrix, okay? What to say at the end? Nothing. It's done. We have just to run the train as usual. And okay, here I'm showing some simple model. I mean, don't care about the results. So only 515 epochs. So, but look at the how amazing is here. Now we have our performance on the archive dataset, and we can compare these results, the train validation and test accuracy, with the leaderboard, so that we know how far we are from the state-of-the-art model on in machine learning, in geometric deep learning. I think it's an amazing tool to start exploring this framework. Just to conclude, I would like to say that, OOGB is an amazing project, is easy model performance comparison, as you said, as you saw. I mean, we run a model, we see the results, and we compare directly. It's a fast way to download it, and if we go on the folder, it downloaded the file containing all the information, proceeded, row, split, mapping, all the information. We also have that you can upload your own dataset. You can upload your own model, like in Kaggle, like you maybe did in Kaggle, and that's all. I mean, I think it's a really good model to use, and there are a lot of data set already presented in the framework, and I'm sure they are gonna expand it and more data set will be introduced. I think it's a great idea. So that's all. If you have any question, please make it.
There are only static datasets in the OGB dataset list.
Okay. Are you looking for temporal network?
No, yeah, just because I have this class in mind. So yeah.
Yeah, I mean, as far as I know, right now there are only static data set, but I don't know. I think they are going to introduce it like because there are there are also other problems in graph neural networks, like heterogeneous graph, stuff on heterogeneous graph. There are stuff on temporal graph. So I think they are going to introduce and expand the framework. As I said, the framework is new. It's I think it's born 2 or 3 years, so it's quite new.
Yeah. Thanks.
Thank you.
I also have a question. Do you know what if there are rules for? So you said that you can submit your own model and it get evaluated. Do you know if there is some kind of moderation or things like that?
Well, you in order to submit your own model, you have to follow a guideline. So, for instance, you have to do at least 10 runs of the same model with different seed. You have to respect a bunch of information, and also you have to load some information about the model, because is it true that the accuracy, anyway, the metrics is important, but you also have to load the number of weights of your model, because it's also important to know how complex is your model when compared with another model.
Okay. I think it will be a great resource also for papers, because you don't need to. So if you have a new model, I mean, maybe you cannot be the state of the art, but you can just upload it and have a comparison without looking for the code and for implementation and everything.
Exactly.
So it's really nice.
Yeah, I really agree with you. So I like this idea, and it's good. Are there other questions? Okay, perfect. Francesco, do you want to do to say what you were?
Yeah. Because there is this open position in the team where I work. So just let me send you the link in the Google chat. So if any one of you knows postdocs, we are looking for 2 postdocs here to work here in Italy, in Milan, and the project is really interesting. And you can find information here in the chat. Please share with everyone. Applications are now open and they will close at the end of October. Yeah, I suppose. And they close, yeah, on the 28th of October. So please share with everyone because we are really looking for these 2 postdocs and we need them to start in the 1st of December in Italy, but there is the possibility to do smart working, so there is no problem. Thank you, Antonio.
Thank
Please,
you.
Sorry, Antonio, Francisco, you can also send the link in the Telegram group if you want.
Yeah, I will send it again in the Telegram group. Yeah.
Thank you, Francesco.
You're welcome.
And hope that you like it, and see you on not next Friday, but the next again. I mean, the one next week.
In 2 weeks, let's say. Okay.
Yeah.
Thank you. Thank you.
Bye, guys.
Thank you, Antonio.
Bye.
Thank you.
Bye bye.
Ciao.
Ciao.